To construct a battery, we need two different types of metal. I have some copper wire here. This is copper house wire, very common. See the copper extending out the end here. The rest of this copper is covered in a plastic insulator. We'll use a wire stripper to remove this plastic insulation. There's some bare copper wire. I'll just clip that piece off. And there's the piece of copper for our battery. Now we need another metal. We're going to use zinc actually. These are a common nail, galvanized. Galvanized means they're covered in zinc. So there's our zinc. There are our two metal pieces, copper and zinc. There's a container for our acid. We need some acid. Obviously we're not going to use a dangerous acid. We're going to use 4% acetic acid. That would be vinegar. Vinegar is in fact 4% acetic acid. Now to suspend our metal into the acid, we're going to use some masking tape on top. And I'll just put a double piece there just to make it a little bit stronger. And I'll use the nail to make a couple of holes. One there and one there. There's our zinc suspended in the acid. And I'll bend our piece of copper a little bit so it doesn't go all the way through the hole. And it suspends in about like that. That should be a battery. Two different metals suspended in an acid. Well, let's check this battery with our voltmeter. Turn it to the 2 volt range. Decimal 984, decimal 985 volts. Almost 1 volt from this battery. I'm touching the plus lead to the copper, minus lead to the zinc. I'm going to reverse the leads here. Black here, red there. Notice we have a minus sign in front of our number now, minus decimal 985. That means I have the leads connected backwards. The copper is the plus terminal on our battery. Let's investigate another very common battery and then find out what we can do with our vinegar battery. This is a AA battery, very common battery, plus and minus as with all batteries, and as we discussed previously, the electrons leave the minus end and are very attracted to the plus end. This is a light bulb, the type of bulb you'd find in a flashlight. I've connected a couple of wires to it. The connection points on a bulb like this are at the base. I've soldered the red wire on there, and around the side, actually where it threads into the holder. And I've wrapped the black wire around there. Completing a circuit here by touching one end to minus and one end to plus, we have our light come on. Electrons flowing from minus to plus. Electric energy changing to light energy. Checking this battery with a voltmeter. Red to plus and black to minus. And see, we have a voltage here of a little over 1.5 volts. These are in fact a 1.5 volt battery. Interestingly, if you take a second battery and touch the plus end to the minus end of this battery, like so, and check the voltage generated here, we have 3.1 volts, a little over 3 volts here. We actually add the voltages, 1.5 plus 1.5 being 3 volts. This is called a series connection. Checking our bulb here and using it with this 3 volt configuration, we can see it is a lot brighter. Adding another battery, we would create 4.5 volts. This bulb, though, is only rated for 3 volts. Could damage it using a higher voltage, so we'll stay with 3 volts. Testing our homemade vinegar battery. We have a voltage of 0.88, 0.89 volts here. Trying our light bulb on that. No glow at all. Let's increase the voltage by adding another one of our vinegar batteries. A series connection requires connecting from minus to plus on your battery. You can use a little piece of copper wire. We'll wrap a bit around our nail. And we'll take the other end and wrap it around the copper over here. Now checking our voltage across here, there's the plus end, there's the minus end. We now have 1.75, 1.76 volts. Let's try our bulb now. No glow at all. The problem is, even though we have the voltage, we don't have the current. This battery won't create enough current or amperage to drive a bulb like this. Let's try a low amperage device. A calculator like this one is a very low current device, using only 1/1000ths of an ampere, maybe 10 1/1000ths of an ampere. Let's shut it off and we'll take it apart. The back is held on with 4 screws, one there, and one here, one down here, and one here. So, we have one AA battery running this device. If I pull the battery out, and we'll note that that's the minus end where the spring is, and the plus end is over here. Pull these connectors up. There's our minus connection. There's our plus connection. Let's put the back on. Leave those wires extended so we can connect to them. There, our calculator's back together. We have a minus side over here and a plus side there. Let's get our vinegar battery. Plus side to plus side. I'm using a red cable for the plus side here. And we'll connect minus to minus Use black cable for the minus side. There to there. We know we have enough voltage. Do we have the current? Pressing on, and we have power. 56 times 3 equals 168. This is a lemon battery. Follow the lemon battery link on the menu and I will show you how to make one.